Yes, children. We saw about stoichiometric effects, that is Schottky defect, Frenkel defect, vacancy defect, interstitial defect, all that we saw. Vacancy defect and interstitial defects, they are in the case of non-ionic solids, whereas Schottky and Frenkel, they are for ionic solids. So we saw that, and we saw the difference between the two and everything. Now let us see non-stoichiometric defects. Now, what is non-stoichiometric defect? It is the ratio of cation to anion is different from the actual chemical formula, right? So this is what is found in non-stoichiometric defects. Now this is of two types. I already told you briefly, metal excess defect and metal deficiency defect, right? Now, what is metal excess defect? Metal excess defect, again, it is of two types. Metal excess defect due to anion vacancies and metal excess defect due to extra cations in interstitial sites. Now what do you mean by this? In the lattice of a compound, an anion is missing from the lattice site, and in the place of anion, an electron is occupied. So electrical neutrality is maintained. Now electron trapped in such anion vacancies, what are they called? They are called F centers. Okay, electron trapped in anion vacancies are called F centers. F means Fab. Fab means color imparting centers. They give color to the substance. Okay, now how do we explain that? Now look here. You are having an NaCl crystal lattice, is it not? Where Na plus is surrounded by 6 Cl minus, 4 I have shown you on the plane of paper, 1 Cl minus above the plane, 1 Cl minus below the plane. Same way, every Cl minus is surrounded by 6 Na plus, 4 on the plane and 1 above the plane, 1 below the plane. Right? Now this NaCl crystal lattice is heated in the presence of sodium vapors. Okay? Now what happens on heating? The sodium, it loses an electron. It undergoes oxidation and it loses an electron and Na plus is formed. Now this is an extra Na plus which is not actually belonging to the crystal lattice. Now what happens on heating? 1 Cl minus from inside the lattice, it is trying to escape out and combine with the newly formed Na plus and form NaCl and will start depositing itself on the surface of the NaCl compound. And the electron lost by the sodium atom, it will go into the lattice and take the place of anion from where the Cl minus diffused out. Okay, now this electron is trapped in this vacancy. Cl minus has gone, so there is a vacancy created, and in that vacancy electron पट से आके वहां पे बैठ गया. ठीक है? This is why you call it as electron trapped in anion vacancies are called F centers. Right? Okay. Now, because of which what you find? This Cl minus has gone with the external Na plus that has been formed now. Okay, so for the newly formed Na plus, there is no new Cl minus in the lattice. The existing Cl minus only has satisfied that. Okay, so what you find here, you will find the metal ion is in excess. Is it not? Otherwise, it was in the ratio of 1:1. Now, the newly formed Na plus is not having its companion. So, this is excess in the crystal lattice. Okay, this is why it is called as metal excess defect. Okay, and the creation of anion vacancies in which electrons are trapped and they are called F centers. Okay, now excess sodium in NaCl lattice is found to give yellow color. Excess lithium in LiCl lattice is found to give pink color. and excess potassium in KCl lattice has been found to give violet color. So this is about one part of metal excess defect. Now look at the next part. What is the next part? The next part is extracations in interstitial sites. Now what is happening here? Say for example, zinc oxide is heated. It decomposes. Okay, on heating it decomposes to form molecular oxygen. Zinc 2 plus and O2 minus, this is what it is made up of, and O2 minus is getting oxidized to give you molecular oxygen. Okay, so what is left behind is zinc 2 plus, and when O2 minus is moving as half O2 plus 2 electron. Right? Now these 2 electrons, and what is left behind is zinc 2 plus. This O2 minus has got converted into half O2. Okay? Now these zinc 2 plus ions, now when you heat it, what happens? Definitely the lattice will be crushed, or a little bit disturbance will be there in the lattice structure. Now the zinc 2 plus ion and the electrons which are formed, they get trapped in the vacant interstitial sites, and the electrons also in neighboring sites. जहाँ जहाँ पे जगह मिल जाता है, interstitial sites पे जाके zinc 2 plus और electrons घुस जाते हैं. ठीक है? Now what you find here? Zinc 2 plus is gone to accommodated itself in interstitial sites, for which there is no oxide ion, because oxide ion has moved or has escaped in the form of molecular oxygen. So the zinc 2 plus ion which is now there in the lattice, they are all extra. Is that clear? So when zinc oxide is heated, it loses oxygen and it turns yellow in color. Right? Because of the electrons. Because of the electrons, it gives that yellow color. Now due to the presence of free electrons, wherever there is metal excess defect, they can act as semiconductors, because in the case of anion vacancies also, electrons are trapped in anion vacancies, so free electrons are there. Same way in the case of zinc oxide also, zinc 2 plus ions and electrons are there. Okay, so these electrons, presence of these electrons make these substances behave as good semiconductors. Right?